Welcome to the video exploring the Moon, our natural satellite. In this video, we will discover the fascinating features of the Moon, from its internal structure to its mysterious surface. You'll learn about the massive craters, the vast lunar seas, and the smooth light streaks left by meteorite impacts. We'll also explore interesting phenomena like lunar eclipses, the Moon's strange motion, and the first astronauts who set foot on the Moon's surface. Get ready for an exciting journey to better understand this mysterious world today. Don't forget to like, share, and subscribe to the channel to stay updated on more exciting exploration videos. The Moon, Earth's only natural satellite, is one of the most fascinating objects of study in the solar system. Below is a detailed analysis of the Moon, from its structure and surface features to the phenomena occurring on it, as well as the astronauts who have set foot on the Moon and the question of whether the Moon harbors life. The structure of the Moon. The structure of the Moon can be divided into three main layers: the crust, the mantle, and the core. Below is a detailed analysis of each layer. Crust layer. The crust of the Moon is the outermost layer and is much thinner than Earth's crust. The Moon's crust has an uneven thickness, averaging about 30–40 kilometers, with the areas of the lunar seas, Maria having a thinner crust compared to the highland regions. Composition. The Moon's crust is primarily composed of silicate rocks, including minerals such as plagioclase, pyroxene, and olivine. Notably, the Moon's crust contains a compound called an orthosite, a type of rock rich in plagioclase, which gives the highland areas their characteristic bright appearance. Craters. The Moon's crust is heavily impacted by meteorite collisions, creating thousands of craters on its surface. These impacts have formed a layer of regolith, fine dust, that covers the lunar surface. Mantle layer. The mantle lies beneath the crust and makes up the majority of the Moon's volume. The Moon's mantle has a thickness of about 1,000 kilometers and is primarily composed of magnesium and iron-rich silicate minerals. Composition. The Moon's mantle is mainly made up of minerals such as olivine, pyroxene, and feldspar, which are rich in magnesium and iron. The mantle of the Moon is less iron-rich compared to Earth's mantle. Properties. The Moon's mantle shows no signs of strong convection like that on Earth, meaning that the Moon does not experience significant geological activity such as volcanic eruptions or earthquakes. This also explains why the Moon's surface is relatively stable and doesn't change much over time. Temperature. The temperature in the Moon's mantle ranges from about 1,000 degrees Celsius to 1,200 degrees Celsius, but due to the lack of a thick atmosphere, the temperature on the surface and within the deeper layers varies significantly. Core layer. The Moon's core is smaller than Earth's core and has a quite unique structure. It makes up about 2% of the Moon's mass, much smaller than Earth's core, which accounts for about 30% of Earth's mass composition. The Moon's core is primarily composed of iron, but in much smaller amounts compared to Earth's core. In addition to iron, the core also contains small amounts of sulfur and nickel. State. One of the unique features of the Moon's core is that it seems to be not completely liquid, but possibly semi-liquid or solid. This is why the Moon's core does not generate a strong magnetic field like Earth's core. Magnetic field influence. The Moon's core does not generate a strong magnetic field like Earth, which may explain why the Moon does not have a clear magnetosphere. However, recent studies suggest that the Moon has a weak and variable magnetic field, which may originate from the layers of material above the core. Surface features of the Moon. The surface of the Moon is very unique and distinct from other planets in the solar system. Some notable features on the Moon's surface include craters. Craters are one of the most prominent features on the Moon's surface. They were formed by impacts from meteorites and comets over billions of years. Features: lunar craters vary in size from small to gigantic, with diameters that can reach hundreds of kilometers. Large craters such as Tycho, approximately 85 kilometers in diameter, and Copernicus, about 93 kilometers in diameter, are easily recognizable from the surface. These craters often have steep surrounding walls and a central peak. Impact of collisions: the impacts from meteorites have created deep craters, but there has been no volcanic activity for millions of years, as the Moon no longer experiences significant geological activity. Lunar seas, Maria. The lunar seas are dark, flat regions on the Moon's surface. In reality, they are not seas of water but vast plains primarily formed from solidified lava. Features: the areas of the lunar seas appear darker compared to the higher regions, highlands, due to the presence of iron oxide. The lunar seas are vast and cover about 16% of the Moon's surface area. Notable examples include Mare Imbrium and Mare Tranquillitatis, where Apollo 11 landed. Origin: the lunar seas were formed by volcanic eruptions in the past, where molten lava flooded large basins on the Moon's surface, filling them and creating vast plains. Highlands. The highlands of the Moon, also known as terrae, are brighter and more rugged regions that stand out on the Moon's surface. Features: the highlands are rich in granite, particularly northocite, and are dotted with many small, rugged craters. The highlands appear brighter than the seas because the rocks here contain more plagioclase, a light-colored mineral. Difference from the seas: the highlands and the seas of the Moon are distinctly different in color and topography, creating a diverse and easily recognizable lunar surface. Regolith, lunar dust. Regolith is a layer of fine material that covers the entire surface of the Moon, formed from impacts by meteorites and comets over billions of years. Features: regolith covers the entire lunar surface and varies in thickness from a few meters to several dozen meters. It is primarily made up of rock fragments, fine dust, and crushed mineral particles. Regolith is very fine and can stick to any surface, including the equipment of astronauts. Origin: regolith is formed by the impact of meteorites, which break rocks into small, fine particles that are then scattered across the Moon's surface. Ray, lunar rays. Lunar rays are bright, fine streaks radiating from craters on the Moon's surface, particularly from younger craters. Features: these rays are formed when materials from meteorite impacts are ejected and create bright streaks extending from the crater. These rays can stretch for hundreds of kilometers and are easily visible from the Moon's surface. A notable example is the ray system from the Tycho crater. Formation process: the rays are the result of debris from the impact being scattered, exposing lighter-colored rock layers beneath the surface. 3. Phenomena occurring on the Moon. The Moon does not have a thick atmosphere like Earth, so it is directly affected by cosmic factors and the vacuum of space. Eclipse phenomenon. Lunar eclipse. A lunar eclipse occurs when the Earth is positioned between the Moon and the Sun, blocking the sunlight from reaching the Moon. This event happens at least twice a year. Features: during a lunar eclipse, the Moon may turn red, also known as a blood moon, due to sunlight scattering through Earth's atmosphere. Significance: a lunar eclipse is a fascinating astronomical phenomenon that can be observed from Earth and provides a great opportunity to study the interactions between Earth, the Moon, and the Sun. Full moon and crescent moon phenomenon. The Moon goes through different phases during its orbit around the Earth, from the new moon to the full moon. Features: the Moon appears full when sunlight illuminates its entire near side, and appears as a half or partially illuminated shape when only part of it is lit up. These phases are related to changes in the positions of the Moon, Earth, and Sun. 4. Astronauts who landed on the Moon. The history of Moon exploration is closely linked to NASA's Apollo program, particularly between 1969 and 1972. The first astronauts to set foot on the Moon during the Apollo missions include 4.1. Apollo 11-1969. Neil Armstrong was the first person to set foot on the Moon on July 20, 1969, and he famously said, "That's one small step for man, one giant leap for mankind." Buzz Aldrin was the second person to walk on the Moon during the same mission. 4.2. Apollo 12-1969. Charles Pete Conrad and Alan L. Bean were the astronauts on the Apollo 12 mission, and they landed on the Moon in November 1969. 4.3. Apollo 14-1971. Alan B. Shepard and Edgar D. Mitchell were the astronauts on the Apollo 14 mission. 4.4. Apollo 15-1971. David Scott and James Irwin were the astronauts on the Apollo 15 mission. 4.5. Apollo 16-1972. John Young and Charles Duke were the astronauts on the Apollo 16 mission. 4.6. Apollo 17-1972. Eugene Cernan and Harrison Schmitt were the astronauts on the Apollo 17 mission. Eugene Cernan was the last person to leave the Moon's surface. 5. Does the Moon have life? The Moon does not support life as we understand it on Earth for several key reasons. Atmosphere. The Moon lacks a thick atmosphere, so there is no oxygen or other gases necessary for life. Water. The Moon does not have liquid water on its surface, though there are signs of water in the form of ice in the permanently shadowed regions at the poles. Extreme temperatures. The temperature on the Moon varies drastically, ranging from about -173 degrees Celsius at night to 127 degrees Celsius during the day, making the environment unstable for life. However, ongoing research continues to investigate the possibility of detecting microorganisms or extremely simple forms of life that could potentially survive under the harsh conditions of the Moon. But to date, no clear evidence of life has been found. So, we've explored the wonders of the Moon together, from its internal structure to the fascinating phenomena on its surface. The Moon is not just Earth's satellite, but a mysterious world full of untold stories. We hope this video has helped you gain a deeper understanding of the Moon and sparked your interest in space exploration. If you enjoyed this video, don't forget to like, share, and subscribe to the channel so you won't miss the exciting discoveries in future videos. Thank you for watching, and we look forward to seeing you in the next ones.